Exploratory challenge, going from a table to a graph. So we're going to go over a couple of questions to review some things that you've learned in previous years about graphing. And then there are going to be some questions on here that you're going to have to come up with your own answer, because I can't give you one about what you see and what you think. We will kind of answer those questions later when we get to the examples. So our first question is, where is the origin? If we're looking at a graph, that origin is in the very corner. Sometimes our graphs will look like this. It's this center point that we start all of our counting from. So I'm going to say the origin is the center of a graph. Its coordinates are 0, 0. All right, our next question. From the example above, what should we label the x and y axis? So luckily in our table they did label those for us. So when we label our graph, we would label our x-axis as candy bars sold and our y-axis as money received. So we would label the x-axis candy bars sold. Maybe we'd do colon here. Candy bars, received. And our y-axis is going to be, or not received, sorry, candy bars sold and money received. There we go. That makes more sense. I was supposed to spell it right too. Oops, I think I switched those around. Sorry. There we go. When we are looking at our graph, just as a reminder that our bottom one is our x-axis and this tall vertical one is our y-axis. All right, our next question. Could it be the other way around? In other words, could we switch what we label the x and our y? And this is where we need to do a little talking about our graph. So when we have our graph with our x and our y, this x-axis is where we graph our independent variable. I know in science, when you make graphs, they help you to remember that by you can take an eye and use the bottom edge of that to make your eye, so that could be your independent. And our y-axis is our dependent variable. And again, we can use that axis to form the D for dependent. Now, why is this important? I left off my T. Why is this important? When we're looking at our examples, such as candy bar sold and money received, the amount of money we receive depends on how many candy bars we sell. For those, number of candy bars sold is our independent variable. So no, the amount of money depends on the number of candy bars sold. All right, so let's look at our next question. Would the origin be included in all proportional relationships? And this is when you're going to do some investigating on, so I want you to take a guess. So I'm going to put a note here for you. Take a guess. Was it going to be yes or no? And then you'll do some investigation when we look at our examples. What do you think the line of a proportional relationship will look like? Again, I can't pick this for you, so you're going to take a guess. Will it be a squiggly line? Will it be a circle? Will it be a straight line? You put whatever you think that answer is. And again, we're going to do some investigating with that here in just a little bit. All right, so you were to get a handout, and we're going to go through here and we're going to work this first handout, and then we will answer this next question. It says, using the ratio provided, create a table that shows the money received is proportional to the number of candy bars sold. Plot the points in your table on the grid. So we're going to make this proportional. So I'm going to go up by 2 more. I'm going to say 4, and I'm going to double that and say 6. Then I'm going to sell 2 more, so 6. And when I go up by 2, I have to go up by 3. So it'd be $9. I'm going to go up 2 more, so 8. And that would be 12. All right, so when we go to graph this, remember our X is down here and our Y is here. So I'm going to go over to 2. And then I'm going to go up to 3, and I'm going to put a dot. Just over 2, up 3. I'm going to go over 4 and up 6. I'm going to go over 6 and up to 9. And I'm going to go over to 8 and up to, oops, lost my line, 12. There we go. All right, so our next question says, what observations can you make about the arrangement of points? So if we look at these points, if we were to connect all of these points together, they would make a line. So I'm going to say, when connected, the points make a line. Okay, our next question, whoops. Can we extend the line in both directions? Explain why or why not. So could we take this line and keep going up here, and could we go down here? So in all reality, we can extend the line, yes, because we can sell more candy bars. So that's kind of extending it up. What happens if we think about extending it down? I mean, we can't sell negative candy bars. I guess people could prepay them and then we would owe them candy bars, so that would kind of work too. With these real life scenarios, it's a little harder to look at those negative numbers that you've been talking about in numeric analysis. All right, our next question here. Would all proportional relationships pass through the origin? Think back to those discussed in previous lessons. So all of those questions that we've talked about so far and all of our examples have always gone through 0, 0. So do you think all of them would go through 0, 0? I'm going to say based on what we've talked about so far. So based on what we've seen, yes, they will all go through 0, 0. Okay. And what can you infer about graphs of two quantities that are proportional to each other? So this is one that I want you to take a minute and I want you to take a guess. So take a guess. We're going to go over these answers. Now, when we talk about the word infer, it's what can you guess, or based on what you've seen, what are some rules that you could say a graph would have to follow in order for the relationship to be proportional?